Okay.
Hey, Miss Joy,
Yes.
you got a little paper I can write on?
Oh yeah, come get it.
I'll come get it. Give it to me.
There you go. Okay. Okay, so we're going to have quite a bit of pre-cal today. And I know some of you don't feel that confident with your pre-cal knowledge, so it's even more important that you listen and pay attention. Even functions, what do you remember? Okay, I'll give you an example of an even function, x squared. Okay?
X to the fourth?
Or x to the fourth. I'll draw a few of them for you. How about that?
So it's just when the exponent's equal.
So let's say, okay, this is x squared. This is y equals, it'd have to be like x to the fourth with other stuff, but I'm going to put x to the fourth-ish. Okay, because it'd have to be an equation with other stuff in it or it wouldn't look like that. Okay. Symmetric across the y-axis. Good. That's one thing I was looking for. So, even functions are always symmetric across the y-axis. Now, for calculus, that's going to be a very important feature because when a graph is symmetric across the x-axis, that affects whether your y values change sign or not when you change sign on x. So, for example, in my first graph, what is f of 2 if x is squared? 4. What is f of negative 2 if I square it? 4. Did the sign change when I change the sign on x? No. Let's go one bigger. Let's say 3. What is 3's ordered pair on x squared? 3, 9. What is negative 3 if I square it? Negative 3, 9. So the property that we're going to write down is that whenever you find f of negative x, it will be the same as f of x. What that means is that your y value is unaffected by whether you're plugging in a positive or a negative of that number. Okay? The other thing that's important for you to know is that when you have an even function, the derivative of an even function is always odd. Okay, the derivative of an even function is always odd. Which brings us to odd functions. So, new little chart thingy. Okay, odd functions. If x squared is even, what would be an example of an odd function? X cubed. And actually, too, I meant to draw on this little fourth power. Let's say that f of a is here. Then what do you notice about f of negative a? They would be what? The same. They'd be equal. Okay, so that should be true if it's an even function. That should be true for literally every possible point on the graph. Okay? Now, for an odd function, we're using y equals x cubed. What would the point be for 2? What is 2 if I cube it? 2, 8. What is negative 2 if I cube it? Negative 2, negative 8. So what do you notice for an odd function? Does it matter if you start with a positive or negative? Yes. So also, do you recall the symmetry for an odd function? The origin. And what does that mean? Because that always sounds weird to me. That you can, rotate it. Rotate it. Okay? So I'm going to put, there is a symmetry about the origin, and then I'm going to put underneath that, that's a symmetry when you rotate 180 degrees. Okay, so the technical way of saying that is it's symmetric about the origin, but a lot of times that seems weird. So I just think about if I rotate it 180, if it's the same, it must have been odd. Now, the other thing that we just talked about with the y values matters as well. If I change the sign on my x, my y's will have to have opposite signs as well. So the way that I would write that is that f of minus a is equal to negative f of a. So if I change the sign on my x value, that's going to result in an opposite sign in my y value. Okay? Yes, that's a good, so think about it. Here it was 2, 8, but when I changed 2 to a negative 2, 8 changed to a negative as well. Okay, so I'm going to put opposite x values means opposite y values. Make sense so far? Okay, now if the derivative of an even function is odd, what do you guess the derivative of an odd function is? Even. So derivative of an odd function is always even. Now, the last thing that I'm going to just mention is that all functions are not necessarily classified as even or odd. Okay, some are, but some are even, some are odd, and some are neither. Okay, so for example, square root x, that's not considered even or odd. That would be just like a nobody, basically. Okay? So the last thing that we're going to do is we're going to graph sine x and cosine x. One of them is even, one of them is odd. You have the characteristics on your paper, don't say it out loud. Okay, but I want you to label which one is which. So first we're going to graph y equals sine x. Then we're going to graph y equals cosine x. So sine x, where does that begin? What value on the y-axis? What'd you say? Anybody? 0. Okay, and then where does cosine begin? Do you remember? Cosine begins at 1. Okay, then here's what happens. For my sine graph, I go up, down, up. And now I'm going to continue that pattern on the other side. So if I was here, I would have gone up, down, up. Mine's kind of squished and ugly, but you get the idea. Okay, now what does cosine do? It starts up. So it goes down, up, and then what's it going to do on the other side? Down, up. So what I want you to do is, in your mind, label one as even, one as odd. Think about it. One is going to be even. One is going to be odd. Okay, guesses? What is sine? Sine is odd.
Odd like a tongue.
Yup. And what's cosine? Even. Okay, now let's plot a few points just to check that. So, if I were to go to pi, what is the sine of pi? 1. What is the sine of negative pi? Negative 1. Yeah? What happened when I changed pi to negative pi? My y value changed sign as well. Okay, what about if, let's say I did 3 pi halves? Okay, 3 pi halves gives me negative 1, bless you. But then what about negative 3 pi halves over here? I get positive 1. So I'm going to write here, this is negative 3 pi halves goes with 1, but regular 3 pi halves goes with negative 1. So what you should notice for an odd function is that when my x's change sign, so do my y's. Now let's do the same thing on our cosine graph. Okay, cosine at pi is negative 1. What about cosine at negative pi? What is it still? Negative 1. Why did the y value stay a negative 1? Because cosine is even. Now, let's talk about the derivative crap. If I take the derivative of cosine, which is even, what do I get? Sine, which is Odd. If I take the derivative of sine, which is odd, what do I get? Cosine, which is even. Okay, so all of that in your mind should make sense. What?
Wouldn't it be negative sign as a thing?
Technically, yes, but if I flip it, it still stays as an even. So that's a good point. Sine and cosine, regardless of a negative or positive in front, will still fit that same category. Okay, sort of makes sense? Okay, so I'm going to do one example off your homework with you. So if you'll get out your homework 8, really this should be titled homework 7. So if you will change that for me now, because I'm going to be gone during the week and I don't want you to be confused. So that should be, I'll be gone Wednesday, Thursday, Friday.
Whoa, 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 Miss Whoa.
I told y'all that for Sky Ranch.
No, you didn't.
Okay? So, homework 7, which it says 8, but you're changing it to a 7. Turn over to the back.
I think it's turned to middle.
Just go put it on my desk, that's okay. I'll give you your notes back when I find them. Okay, turn over to the back. We're going to do number 7, this one right here. No, you'll get more.
Friday, right? Let's do Friday, right?
Actually, I'm going to have it all be due Monday because I don't want you turning in a bunch of stuff to the sub. Okay, but over Thanksgiving break, you're not going to want to do it. So just in your mind, think it's due Friday. Thank you. The goat. Thank you. Okay, here we go. Okay, look at your number 7. Shh, shh, shh. Okay, it says f and g are differentiable functions. Now, you guys have seen this word a bunch. Differentiable just means you're allowed to take the derivative. Okay? Differentiable just means that you can take the derivative. So don't think that that's anything complicated. It just means when I take the derivative, I'm going to get an answer, not like an undefined or something weird. Okay, then it says f of negative 2, blah, 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 f of prime of negative 2, blah, 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 a bunch of info. Then it says that f is what type of function? Okay. Odd like a Todd. So I want to find f of 2, then I want to find f prime of 2. So let's go step by step. Remember that f is odd. F of 2, we want to know what it is. What did they give me for f? F of negative 2. What was f of negative 2? 3. So I'm going to write, it's given that f of negative 2 is 3. Well then if f is odd, and I change the negative 2 to a positive 2, will my y value also change sign? For an odd, the answer is yes. So if this was a 3, this is a negative 3. Okay, now listen, if f is odd, when I go to f prime, what will that be? Okay, then f prime must be even. Now, I want f prime of 2, but I don't know what that is. What did they give me, though? F prime of negative 2. What did they tell me f prime of negative 2 is? 5. Yeah, so if f prime of 2 of negative 2 is 5, then when I change the negative 2 to a positive 2, should I change the sign on 5? No, because it's even.
So you got negative 3 and positive 3 from the question.
Yeah, right here,
It always starts off.
they gave me that info right there.
Then you get to where they go.
Yep.
So they give you one and you figure out the other one.
Yeah, you're basically just changing the sign on x and then deciding if you're changing the sign on y as well. Okay, now, what did they ask you to do? Write the what? Shh, shh, shh. Okay, what 2 things do I need for an equation of a tangent line? Okay, now, what is the x value of the point that they gave you? So what is the y value for the point? Do I want f or f prime? What is f of 2? Negative 3. Next, I want my slope at 2. If I want my slope, am I doing f or f prime? What's f prime of 2? 5. Then from there, I know everything I need to write the equation of my tangent line. So it should be y plus 3, slope is 5, x minus 2.
I'm so glad I got that.
Okay, there's one more right below it. Okay, but instead of a 1, it should be a negative 1 here. So if you'll fix that, I'm going to give you a minute or so to do it. Yeah,
Can I go to the bathroom?
you may.
Okay.
Okay, now look. Your G info is right here.
I'm already hurting.
Okay, but they're telling you this time that G is even. So remember, when it's even, I do not change the sign on Y, regardless of whether X changes sign. But then the derivative of G will be odd, and there you will change the sign. So do it. I'll give you a minute to write that out. Bless you.
So you would do G of negative 1 and G of G prime.
Mm-hmm. Okay, if you need help on the first part, G is even. G of 1 was given to be 4. Then what is G of negative 1? Still 4. Why? Because if it's even, the Y value stays the same. Okay, now if G is even, what is G prime? Odd. And if G prime is odd, and I want G prime of negative 1, then I need to use what I was given about G prime of 1. What's G prime of 1? Negative 3. And if G prime of 1 is odd, then G of negative 1 would be positive 3. It was given up here at the top.
I did not see it.
Okay. Okay, good. Okay, then from there, to write the equation by tangent line, I need a point and a slope. What's my x value of my point that we corrected? Negative 1, right here. So if I want negative 1, do I use G or G prime? G. Negative 1, 4 is my point. And then what's my slope? Positive 3. So it'd be y minus 4, 3 is my slope, x plus 1. Oh, that's ugly, but oh well.
So are we still going to have examples on the notes or not?
Of that? No.
All right.
Actually, tomorrow we'll do more notes, and there'll be examples of it just to remind you. But
For like both questions, we're not supposed to plug in 2 for L.
what do you mean by plug in 2 for
Then
x?
write the equation of tangent line to add x.
Well, so this one says that x equals negative 1.
Yeah.
So that's why we did it. And then this one said at x equals 2.
So we're not plugging in that for F.
Well, you are plugging it in for f, but you don't have an equation for f.
No, I'm asking if we put it to the tangent for F.
No, because they didn't give us a decimal to plug in. Yes. Huh? Yeah, Jeremy. The slope is 3 because it's G prime, correct. And remember that G is going to give me the point, and then G prime is going to give me the slope. Okay? Yes. The G prime here? Yeah. Okay, listen, y'all be quiet. Okay, if G is even, G prime switches to be odd. And remember that for odd functions, if you change the sign on x, you have to also change the sign on y. So if G of 1 is negative 3, then G of negative 1 needs to be negative 3. And then those negatives switch to a positive. So what I would remember is that for even functions, your y value is always the same. But for odd functions, your y values get to switch signs. Okay? Okay, are we good to go on?
Wait, can I use the restroom, please? Yes, ma'am.
Okay, go back to your notes. So we have covered even and odd. Now we need to talk about inverses. Okay, here we go.
Back to notes.
Yep. Okay, so look at your title. We've covered even and odd. We still have inverses left.
Let's not do that part.
Okay, what do you remember about inverse functions?
They're scary.
No.
They are. No bueno.
Okay, give me examples. So inverse functions always cancel each other out. So just give me a few examples of inverse functions. Let's say x squared. What's its inverse?
Square root of
Okay, good. So I'm going to do y equals x squared. His inverse is y equals plus or minus square root x. Right? Because how do I get rid of a squared? I take the square root. So let's sketch a little graph. Okay, here's my x squared graph in black. Now I'm going to draw my plus or minus square root graph in red. Notice what happens with your graphs. This is my positive square root. This is my negative square root. What do you notice about their graphs? Are they still a reflection of each other?
No.
Yes. I'm going to give you another one. It's not a rotation, it's a reflection. Let's do another one. E to the x. What's his partner?
How is it a reflection?
I'll show you. Okay, e to the x and ln x, they're partners. So let's sketch their graphs. Here's e to the x. Here's ln x. Okay, now remember, I don't have to reflect across the x or the y-axis. I'm allowed to also reflect across diagonals.
Yeah, that one's like that makes sense to be a reflection.
So look, if I draw this in here, okay, do you see that it's a reflection? What about here? If I draw it in through the diagonal,
But that's also a rotation.
okay, you're right, but remember that it will always be a reflection. This is not a rotation.
Right.
So the problem is you have to pick what it will always follow. So you're right, this one could also be drawn as a rotation, but they can both be reflections. Okay, I'll give you one more. Okay, last one. Let's do y equals x cubed and y equals cubic root x. Okay, what does y equals x cubed look like?
Something.
Okay, like that. And then what does cubic root x look like? It looks like that. Okay, that's your cubic root x. That's your x cubed. Okay? Now, let's talk about some other stuff. So outside of the fact, and actually we need to write our first bullet point. So our first bullet point is the graph of f and f inverse will always be reflected across the diagonal line y equals x. So if I were to draw that in here, my graph kind of sucks. Okay, but you would see a perfect symmetry around that if it was drawn well. So f and f inverse will be symmetric across the diagonal line y equals x. And so if I want to, I can label that on here for you, y equals x.
¿Puedo ir a varios?
See?
Gracias.
Okay, what else do you remember about inverse functions? Anything else? Specifically about their domain and range.
The same. Oh, negative infinity to positive infinity? I don't know.
All real numbers.
Okay, hold on. What is the range of the black parabola?
Infinity.
No, range.
0 to
Infinity. What's the domain of the red parabola? 0 to infinity. So the domain of f turns into the range of the inverse. What about here? What's my range? 0 till infinity. What's my domain here? 0 till infinity. Okay? So your domain and range, domain of f is the range of f inverse. Okay, so then I'm going to put underneath that x and y are switched. Now, I don't like when you guys say they're opposites. Technically, an opposite's like you're changing sign. That's not what's happening here. So they're switched, they're reversed. Okay, but don't say opposite because technically that really is wrong. Make sense? Okay, now just as a little warm-up activity, we're going to practice finding inverses to make sure that you remember how to do it. So the first thing that I'm going to have you do is find the inverse of f of x equals x squared minus 6. Okay, do you remember how to find an inverse at all? Okay, step number 1, you are going to switch x and y. So instead of being f of x equals x squared minus y, it's going to be x equals y squared minus 6.
Why do you switch it?
Because inverses, the domain and range are backwards.
So you would just move the x and the y, but leave
You would basically reverse them, correct? Then from here, what would I do?
PEMDAS backwards, add 6.
Okay, add the 6 across, good. So I have y squared equals x plus 6. What would my next step be?
Square root it.
Square root both sides. So I'd have y equals plus or minus x plus 6. What that means is that f to the minus 1 of x is that function. So these two functions are inverses of each other. Okay? Those two functions, this one and this one, are inverses. What that means is, if I graph them, they'll be perfectly reflected across the diagonal line. Their domain and range will be exactly reversed. And any point on one will be backwards on the graph of the other. Okay? Alright, we're going to do one more like that, then we're going to get into their derivatives. Okay?
Okay. Wait, do you think this will be enough space for the second example?
No. Okay, next one we're going to start with a cubic root. You ready? Okay, one more. You are going to find the inverse of f of x equals, we're going to do the cubic root of x plus 7. 7 is on the outside of the cubic root. First thing that I'm going to do is switch my x and y. My f of x is usually a y, now it's an x. My cubic root of x is now a cubic root of y plus 7. From there, what do I do with the plus 7 to cancel it out? Minus 7 minus 7. Then I have the cubic root of y equals x minus 7. What do I do to get rid of a cubic root? Cube and cube. So then I have y equals x minus 7 cubed, which means that f to the negative 1, or f inverse, is x minus 7 cubed as your answer. Now let's talk about some things that we noticed. Yes, ma'am. Okay, when I had a plus 7 on the outside of the root, what did it turn into?
Minus 7.
A minus 7 on the inside. When I had a cubic root, what did it turn into? A cubed. So you should notice that some of those patterns are going to stay the same. Okay, let's look back at our other one that we did. I had... No, you are going slow because you are dodoing around. You are playing on your phone. And King?
I'm not playing on my phone. I got all the notes right here.
You do? Okay.
So how about you
I take it back.
Yes, miss, I can't keep up.
Okay, look. When I had a squared, what did it turn into? When I had a minus 6 on the outside, what did it turn into?
Plus 6.
Plus 6 on the inside. Now, I'll also add, guys, the reason I'm going a little fast is you already learned this in pre-cal. So this is technically not something I should be teaching you. You should already know this.
Mr. Armstrong.
Okay, but I'm keeping up.
Good.
Keep up.
Hey girl, you fast. Chill out.
Okay. So,
Miss Joyner, so if it's on the outside, you automatically move it to the inside. On the inside, you move it to the outside.
yeah, it's kind of a lazy way to do it, but that's always going to happen, yes. Okay, so here we go. Number 1. Okay, this is exactly what you're doing on the homework. It has several steps. So I'm hoping that we can at least get through one. Okay, are you ready?
Yes, sir. Ma'am. Hey,
You want to connect them for 2 numbers?
Hang on.
I have an 8 in the class. I don't know how to do it.
Okay, this is what you are doing on your homework. You are going to prove that inverse function slopes are reciprocals of each other. Okay, so this is the new property that you would not have learned in pre-cal. Okay, so the first thing I'm going to do is I'm going to take the derivative, and then I'm going to plug in my x value. So, if I have y equals x squared at x equals 4, actually, let me add one more step. We need to find the whole point. So, number 1, you're going to complete the ordered pair. If they give you the whole ordered pair, obviously you don't have to do this. But if they're only giving me an x, that's not enough. So if x is 4, I'm going to plug that in. Now it's a 4 squared, which means that y is what? So what's my entire ordered pair? 4, 16, right? Okay, from here, step number 2, I'm going to take the derivative. Now, for x squared, that's a nice, easy derivative. What's the derivative of x squared called? 2x. Okay, then I'm going to find the slope at that point. So if my derivative is 2x, I'm going to find the slope at my point, which means that I'm finding y prime of 4. 2 times 4, what do I get? 8. Now, someone in the other class was like, well, wait, I thought I always needed an x and a y for slope. That's only if it's implicit. If it's a regular derivative, the only letter in this guy is an x, then the only letter that I need is the x value. Okay? So, draw a line. You are done with the first half of the problem. The second half of the problem, you are going to find the inverse, which we just practiced.
Whoa, dude, this is what I'm saying.
Because you have been texting on your phone, and I don't have time for that crap.
Focus. Oh my god.
Okay, you could be doing this, though. So, what do I do first to find the inverse?
Flip x and y.
Switch x and y, so it's x equals y squared. And then I need to square root both sides. So when I square root and square root, what does y equal?
Positive, negative, x.
Now, technically there's a plus or minus. I'm just going to pick the positive, though. We'll talk about how to pick that later, yes?
So the x equals y squared, whatever that is, that's the original.
That's the original, but the x and y's are
Okay,
backwards.
so then that's just a simple.
And then I just solve it for y equals. Then from here, I'm going to take the derivative. So I found the inverse. Technically, that should be actually a 4. Okay, can't count.
Negative
After I find the inverse, I'm going to take the
Negative
derivative.
1. Negative 1.
Close. How do you change a square root? Not to a negative 1. A 1/2. Yeah? Now, did I take a derivative with that? No, I just did a rewrite. So, now that I have my rewrite, let's take the derivative. So, y prime equals, what's going to happen with my 1/2 up here at the top? It's going to come down to the front, and then what's the new power going to be on x? Now it's to the minus 1/2. Now, from here, my original ordered pair was 4, 16. For f inverse, domain and range are always reversed. So what is this guy's point? At 16.4. Well, then if I want the slope at 16.4, I need to plug in not the 4, but the
X.
16, which is my x. So step number 6, I'm going to find the slope at that point.
You already have all the stuff you need for the slope, though.
Yes, yeah. So I have y prime equals 1/2 of 16 to the minus 1/2. Well, I'm not going to leave it like that. What is minus 1/2 the same as? A square root, but on the bottom. So that'd be 1/2 square root 16. What's the square root of 16? 4. What's 4 times 2 on the bottom? 1/8. Were your slopes reciprocals?
Can we leave it?
Yes.
Can we leave it on
Oh, no, next.
Well, the whole point is you're trying to show these are inverses.
Oh, okay, yeah. So it's basically.
Yes. So when you take the derivative of a function, its slope will be the reciprocal of the derivative of the other function if it's the inverse.
It makes sense now.
Okay, now listen. We are behind schedule, but we will do a couple more of these tomorrow. Okay, but I need you to bring a lot of
You see?
effort. Okay, good.
Same time as you.
Okay, you have 3 minutes till the bell. And then you should have turned in your homework 6.
Can I turn it tomorrow?
Dennis, you gotta talk for real. Hey, this coming Saturday?
Okay, did you take